Okay.
Okay,
Hello.
we are carrying on question 6.
Yeah.
Right, this is a question that we just solved. They take you through step by step lah, from simple to complex lah. Then we stop at 6B, right? Full wave rectification. Both cycle, there is rectified. Then you are supposed to draw lor. Memory work that is one, nothing much. I remember the two arrow same direction, two arrow same direction. Where they start, you join to Z. Right? Where they end, you join to Y. X and Y are the load lah. As long as you got four diodes shown with correct symbol correct, four diode, right? Wrong direction doesn't matter lah. You get 1 mark lah. Four diode correctly connected to form a bridge. If it's correctly drawn, then you get the second mark lor. Any comment?
No.
The input is at the junction where the two diode meet lah. Right? The two arrow meet. That's the input. Usually they will ask you about discharging lah. Partly because discharging came out in two new syllabus lah. So they might have combined together lor and test you lor. Determine the value for time constant for the discharge of the capacitor C through the resistor R. Okay, how do I do that? How to find the time constant? Go to the data sheet lor. Formula sheet. This is given. This is what they want you to use. Right? Instead of X, you use V lor. That's where you start lor. That's your X naught. And this is the time that it discharged to lor. Okay, so these are the 2 points that you need to read lor. Right? So instead of X, you use V lor. And then I take the V naught down and I log it lor. Right? This is 12. That one is 8 minus your time from here to here. It's about 7 point, slightly more than 7 lah. Right? So it's 0.0073 lor, right? Millisecond. Okay, Ken?
Yeah.
Capacitor C has a capacitance of 570 microfarad. Use your answer in part 4. Determine the resistor of the resistor. Right? And constant is RC. The RC is 0.018. We just calculated it out. Then calculate your R. Okay. Anything need to explain further?
No.
Okay. Okay. Define for me magnetic flux density. Ken?
Force per unit length per unit current
Ah,
in a wire perpendicular to the magnetic field.
remember it's F equals VIL. Force per unit length per unit current. Length or current perpendicular to the field. Okay, a particle, that's your particle, of mass M and charge Q, right? Positive charge. move at speed v into a region of uniform magnetic field. There's a region of uniform magnetic field. Uniform magnetic field is into the page, and has a flux density B. The particle enters the region of field at Y. That's where it enters at Y. State the expression in terms of the term, in terms of sum of all, in terms of sum of all of M, Q, B, and V for the magnetic force that acts on the particle when it is at Y. Okay? This one is memory work. Lor. F is BQV. Lor. This is perpendicular. On figure 7.1, draw an arrow at point Y indicating direction of the force. So it means left hand rule. Where's the direction of the force? Yep, upwards or downwards?
Um,
Right, field is into the page. Current is to the right. Force is outwards, so can get or not? There is a
yeah,
force.
can.
On figure 7.1, draw a line to show the possible path for the particle through the region of the magnetic field. Right? Remember, Cambridge like to use line. Line can mean a curve.
Upwards. Curving upwards.
Draw it to be a circle. Can use a 50-cent coin or use a compass to draw. There's the center. Okay, any comment on that? If not, let's carry on. Right, that's the marking scheme. Explain how an electric field can be used with the magnetic field to ensure that the particle pass through point Z. Okay, how to explain 3 point? Can or not?
Uh,
First, you got the electric force. Sorry, first you
apply
got
downwards.
uh, first
Electric field.
magnetic force. So you need the electric force to be downwards to balance it. So the electric field must be coming downwards. So the electric field vertically apply vertically downwards. Direction electric force on particle in opposite direction of magnetic force. Right? These two must be balanced. Particle are deflected when magnetic or electric and magnetic force are equal. Right? Make sure you got your 3 points correctly, clearly spelled out. Derive an expression for V in terms of B and electric field strength. Right? They ask you to state, then you just use whatever you have stated. For no deflection, magnetic force equals electric force. Right? Q cancel off, V equals E over B. Okay, okay, not okay, not
Yeah.
okay. State what is meant by the Broadie's wavelength. Yep.
Uh, Wavelength associating with a moving particle.
Wavelength associated with a moving particle. And next part is to use the formula calculator. Right, you got electron moving with the speed there. They ask you, they ask you to use the formula to calculate. Lambda equals p h divided by p. P is momentum. There's your h from formula sheet. Mass of electron. That's the speed of electron. Okay, can. Yep. Any comment? Anything not clear?
Yeah. Okay.
State one similarity and one difference between electron and positron. Yep. What's the difference? Similarity.
Both same mass.
Both what?
Same mass.
Okay, good. Different.
Difference one is negative, one is positive. Electron is negative.
Okay, good. These are marking scheme answer lah. An electron moving with a speed 4.9 times 10 to the power 7 meter per second collide with a positron that is traveling at the same speed in the opposite direction. As a result of collision, two gamma ray photons are produced. State the name of the type of reaction. What do you call the type of reaction? Yep. What do you call the name of the type of reaction?
I don't know this one.
Annihilation, no? Pair annihilation. Say what happens to the
Oh,
electron
okay.
and the positron.
The mass of the electron and positron convert into energy of gamma ray photons.
Okay. Their mass gets converted into energy. Mass energy becomes energy of gamma photon, no? Right? Two gamma photon produced. Explain why two gamma photons are produced rather than just one. Yeah.
They travel in opposite direction
Yeah. Why are they traveling in?
to keep to conserve the momentum.
Momentum is conserved, no? They travel in opposite direction to conserve momentum. And this one is more calculation only lah. Show that the kinetic of electron before collision is that. Your AS work, half mv square. Right? Mass of electron get from formula sheet. Speed is given. Speed given from the part B there. Calculate out. Lor. Okay. If I'm going too fast, stop me. Use your information in D part 4 to determine the three significant figures of wavelength associated with gamma ray emitted in a collision. Trying to get it to use the formula. Right? We'll calculate the kinetic energy. Right? Remember, we calculate only for one only. So we use quantum mechanics to help us calculate the wavelength. And then this formula where the mass is converted in energy. Kinetic energy of electron plus energy equivalent of electron, right? This is we use this formula, and this part we use this kinetic energy, because energy of gamma ray, right? That's the energy of the kinetic energy electron. There's a conversion, delta m, mass of electron, speed of light square, and we use this one, no? Planck's constant, speed of light, lambda, calculate out, can. Okay, define activity of radioactive sample. Yeah,
Number
basically,
of radiations, but
say again,
the rate of radiations. Eh?
disintegration, number of nuclear disintegration per unit time.
Oh,
I worked through the paper. I can understand that now there are a group of new examiners, not the same as the old examiner. The old one probably retired because their testing is different.
huh?
Explain why the variation with time of activity of a radioactive sample is exponential in nature. This one you have to know how to derive. Then you can use that to explain. Can
Activity is directly proportional to uh number of decade, like
activity is proportional to number of undecayed nuclei. That's what it means. So this one, and this is activity A. Then activity equals to negative rate of change of number of undecayed nuclei. This is equals to A. N is proportional to the rate of change of N, so exponential in duration. So basically, that is the formula. And if you integrate it, you will show that exponential equation. That's what this is all saying. Right? So memorize. Memorize. They don't ask you to derive. They ask you to explain. Okay. Happy with that?
okay.
A sample contains single radioactive isotope that decays to form a stable isotope. The sample has an activity of 180 becquerel at time t equals 0. At times 8.4 minutes later, the activity is 1.2, 120 becquerel. Determine the decay constant in per minute of radioactive isotope. How do I do that? Any idea? Any suggestion? Go to the formula sheet. That's the formula. You want to find lambda. You are given initial x naught, and after a certain time, 8.4 minutes, 120. So use that formula. Right? I take the log of it. A is 120. A naught is 180. Time, right? There's a negative there. Lambda time is 8.4 minutes. And calculate out. Can? Anything not clear? Then the
Okay.
next one is use this equation. No? You can either use this number or use ln 2. No? Okay.
Mm.
Okay, let's carry on. They are very popular these days, asking you to draw the graph, to sketch the graph. So all the points that you have calculated, should be there. Lah. You started with 180, and you already calculate the half-life. You calculate 120. This one given 120, 8.4 seconds. There's another point here, and then there's another point there, right? And half-life, like 40 minutes. You calculated there. So 40 minutes, 180 to 90. So your curve should pass through this point. Something like that. How do they mark you? Line with negative gradient, as long as you have got this graph, doesn't matter how it's drawn, passing through this point. You get 1 point already. Curve with a negative gradient, passing through this point. Another mark, and then passing through curve with decreasing negative gradient from 0 to 0.24, passing through 1490. It's 14, this 90. Okay. Make sure your curve passing through all these 3 points, and then up to 24. Any comment? Anything not clear?
Yeah.
Take Haber's law. Okay, without looking at your answer, it's Haber's law. All this must be at your fingertips. These are points you cannot afford to lose. These are points you're supposed to gain. Memory work only.
Uh, can I just say the velocity directly proportional to distance?
They probably give you 1 point only. Speed is
Shit.
directly proportional to distance. Speed is the speed of recession of galaxy from the observer, and distance is the distance of galaxy from the observer. Okay? A star in a distant galaxy emits radiation that has a maximum intensity of emission at wavelength that observation of the galaxy made on Earth detect the maximum intensity of emission from the star at wavelength that explain why the observed wavelength and the emitted wavelength have different value. Yep. Observed wavelength is the wavelength of the color light on Earth lah. Wavelength of the color light, then the same wavelength, the same color, you look at it from the galaxy, it has different wavelength lah. Galaxy is receding from the Earth, that's your first point. Observed wavelength is rate shifted from emitted wavelength. right? It becomes longer because the galaxy is moving away from the Earth, no? Shifted to the red end, no? Okay.
Okay.
Calculate the speed of star relative to the Earth. How to do that? What formula to use?
Delta lambda over lambda equals to VOC.
Go to formula sheet, no? There's a formula, right? There's a formula. They won't give you a mark for quoting that. Right? You're just using this one and that one there. And V is C times that. Right? This is the wavelength minus that wavelength divided by this wavelength. Right? This is the actual wavelength on Earth, and times the speed of light. Wavelength of maximum intensity of emission is used to determine the value for the surface of the star, surface of temperature of the star. Explain how the temperature determined using observed wavelength compare with the true value of temperature determined using emitted wavelength. Yep, you have to go to wave displacement law. Yep, we are using this one to calculate. Right? If you use this one to calculate, you get different temperature. Use this one to calculate, you get a different temperature. Right? According to that one.
So wavelength for maximum intensity is inversely proportional to temperature.
That's your first point.
As lambda increase, temperature decreases. Is that the second
Right?
one?
Observed wavelength is too high, so determine temperature is too low. Okay? Any comment?
Oh, correct.
You try to cover as much as possible lah. Astronomy is very popular coming out because it is news introduced only in 2022 lah. So they got a lot of question to set lah. All the others are old one. That's why you don't see X-ray, ultrasound, but they do come out once in a while. Okay, any comment? If not, let's go to finish the last part. Value of Laplace constant is given. Use your answer in B part 2 to determine the distance of the star from the Earth. How to do that? What formula to use? You got 10 more minutes.
V equals
Right? That's the speed.
HD.
H naught D and calculate. Put in the value. H naught is given there.
8.3.
V is that one there. Okay. Any comment?
Yes.
Okay, let's go to
No.
then. Okay, there's now this. My naughty dog is making noise again. Ah, yeah. Okay, let's discuss this paper. May, June 2025, 42. Define the radian. I think this is the paper that you all be doing. Can remember what is the radian?
The angle subtended at center of the circle. When linear displacement is the equal to the radius.
Angles are there at the center of the circle, where the arc length equals to radius. This rear wheel and pedal of a bicycle are connected by chains that passes around two clocks, two wheels as shown in figure. Right? Not drawn to scale. Small clock, one radius is given and is fixed to the rear wheel. This is the rear wheel. So that it rotates with it. The large clock, that's the last one, has a radius of 15 meter, 0.1 meter, sorry, 0.15 meter, sorry, and it's fixed to the pedals so that it rotates with them. Right? The pedal is the one moving, this one will rotate with the pedal. The rear wheel has a radius of 4.6, right? Given there. The bicycle is being pedaled so that it moves in a straight line at a constant speed of 17 meters per second. Calculate the angular speed of the rear wheel. Okay, how do I calculate that? What formula to use?
Angular speed is the E equals R omega.
V equals to R omega, okay. And you can calculate omega, right? That's a, right? Since the speed is a linear speed, right? It's due to the motion of this circle rather than this circle. Right? That's why you use 0.46. Okay, 37 radian per second. Okay,
Okay.
calculate the period or rotation of the small clock. Right? Angular speed is the same for the whole thing. So you use angular speed rather than linear speed. Omega, they calculate it out and calculate period. 2 pi over omega, 2 pi over 37. Show that the distance moved by x on the change during the full rotation of the small clock is 0.24 meter. How do I calculate that? What formula to use? Right? X equals 2 pi r. On rotation is 2 pi r. R is the radius of this one. Because this is the one that produced at x, at distance there. 2 pi, that's the radius. Use your calculator. Okay, anything that I need to explain further?
So
Okay. Use your information in part B part 3 to determine the angle through which the large clock rotates during one full rotation of the small clock. More mathematical lah, this one. Right? That's very calculated. Your distance x, then you apply it to here. Your distance x is that distance x, the arc there, the radius of that wheel, then can calculate your theta. That's the radius, 0.15. That's the distance move we have calculated just now. Can
Yeah.
the change of the bicycle is it move onto a smaller clock fixed to the rear wheel. The speed of the bicycle does not change. Explain without calculation the effect of this change on the angular speed of the pedal. Right? This one is next
It's the
one.
formula to explain, right?
Usually you use a formula to explain, no?
The
Right?
radius decrease, distance moved by x in the same time decreases as well.
Right? Point x move through a smaller distance in the same time, in smaller radius, smaller distance. Angular speed of pedal decreases, no? Right? Basically, they just want you to go through the whole question again now, making this smaller. That's how we calculate our omega. One smaller, and one smaller, right? So that's why we get our angular speed, no? These are other alternative answer lah, given by the marking scheme lah. Okay lah. Anything need to explain further?
Yeah.